Well, it only took me a week of experimenting, but I think I finally got it figured out. So I realized this is what a big mess. I made a couple of mistakes. First mistake was not adding a flyback diode to the coil. The reason I didn't put a flyback diode, which you can see right there, is because I thought since I was physically interrupting the switch that it didn't matter. Turns out it does. It throws off a tremendous EM field whenever it does that, basically. It's my theory, not quite sure. But when you energize a massive coil and then suddenly turn the massive coil off, you do kind of get a pulse that goes everywhere. Here's the traces again. I realize it's blinking because if I run it too quickly, you won't be able to see much. Essentially, you have two traces interposed. The first trace is the pulse width mod, the pulse width modulation, which is maintaining the charge. The second one is the actual voltage level. I'm showing them both at the same time. I have them at alt. If I do chop, it'll look a little nicer, but yeah, essentially. So what I'm going to what you see here is the terminal screen. Whenever the device resets, and I didn't mention this before, here's the reset switch. You'll see that the screen resets itself, okay, because it's reconnecting the device. So that's how I could tell that it was resetting itself before. Now, hopefully this time it won't. Cock it. Not that it matters. It seems to work either way. And I'm going to fire it. All right. Did it reset? No, it did not. How about that? I'll explain the other things I did wrong here. I should be able to be a little abusive to it. Click, click on, click, 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 click. Okay. Did it reset? Yes, it did. Well, but I was really mean to it. If I'm not so mean, you watch the power supply here, what it's drawing. You'll see that it blinked to constant current because it's actually drawing quite a bit of power when it fires. See, it didn't reset that time. If I hold a dead short on it like this, you know, for an extended amount of time, I'm really stressing the circuitry hard, and it's almost guaranteed to reset, and that's what's going on. But in the low duty cycle, it'll be fine. So the first mistake I made was to put a massive honkin' capacitor on the actual output stage of the booster. That you saw how long it took for it to charge up, to recover. Watch how long it takes for the voltage to recover now. It's hard to even see it go down. It pops right back up again. I did a digital capture on it. It's something like 10 milliseconds to actually fully recover. And the reason is now I'm using a tiny little 10 microfarad capacitor on the output stage of the booster. I might go a little bigger. I might go 15 or 20 microfarad. I'll have to do a little bit more experimentation, but that's what I'm using, and that's why it charges up so quickly. Fires the solenoid just fine. The other mistake I was making was this capacitor right here. I didn't have a capacitor on the input stage to the voltage regulator, so it was browning out the board because it just didn't have enough, just didn't have a deep enough well of charge. So I've got it working now, and I didn't have to use the DAC. I did not have to use the digital analog converter to set the voltage. I'm actually using an inboard 64-bit, what's it called? Some kind of voltage referencey thing that's on the comparator. So now I can set the voltage dynamically. Right now it's set to 9 volts. If I do, that's I believe 14. If I set it to 12, you'll see it's at 8.6. Now it's very coarse adjustment. I can set it to, that's 12, 13 is 9.3 volts, 14 is the 10 volts, 15, and so on. However, this is the output stage of the booster. If I set it to, that's 15, set it to 17. You see how quickly it's adjusting its voltage. I can set it much lower too. If I set it to 5, for example, it's going to be, well, basically it's hardly changing at all. 6, 6, 7. Okay, so you can, the point is here, showing this, is it means that you can actually adjust the voltage of the booster with software. You can just set up the command and fire it as much, fire it with as much current as you are, voltage as you want. There's really no upper limit to it other than what the booster can do and what it can be sensed. I think right now the capacitor can take 16 volts. I think I have on there a 16 volt capacitor. Capacitor voltages, in order to have higher voltages, they need to be physically larger. So they take up more space. I want to set up a compromise. I mean, paintball guns, they don't run off of more than, most of them run off of 7 or 6 volts, and I think occasionally I've seen one that really needs the 9 volts to fire it. I don't think it'll be a problem. I'll set it up with a decent enough capacitor. If I can find like a 20 or 25 volt capacitor, so if you want to run the board with that much voltage, you can. The voltage divider can sense voltage up to high. I have it set up, I think, with a 100K to 8K voltage divider, so it can probably sense up to 30 or 40 volts before it don't go that high, and replace the capacitor before you do it. Then it becomes more of the hobby board. For paintball, it should be no problem at all. Next stage is going to be, or next thing I'm going to do now is actually program the onboard MOSFET to fire solenoids and make sure that it can never reset. I'm going to make, like I said, I was physically doing the thing, and sometimes I was quick enough, sometimes I wasn't. I'm going to make sure that even with a nice long duration, you can't cause the board to brown itself out. See you next time.